the land is a lot of fun. One of the things we've started doing are these Threat Thursdays, where we pull a particular threat actor and do cyber threat intelligence. Then we talk about how to emulate them and then how to defend against it. We've been working with the healthcare sector, and the one we chose this week, the threat actor, is called Orange Worm. They go after healthcare, and everything they do is living off the land. Like literally, they don't do, and like the only third party is their dropper, but everything else is just like netsh, command.exe. They don't even use PowerShell. So it was fun. Like normally what you can do in like one script came out to like 30 steps of living off the land, but of course it's just a lot harder to catch. So interested in seeing your presentation. And
sure.
I guess with that, let me intro you, because it is 1:15 and we are supposed to start. So we have Mike with us. How do you pronounce your last name, Mike? I'm not even going to try.
Gualtieri.
Gualtieri. See, my last name's Orchillas and everyone butchers it. So we have Mike today. He's a technologist and entrepreneur who is passionate about Linux, free and open source software, digital privacy, and cybersecurity. He's the president of the software development firm Iris Interactive Group and co-founder of Savio. And you are also an instructor, so love talking to fellow instructors and giving back to the community. I have a fun bit here that I want to read about Mike, that he started in security at a very young age. I don't know how many of our listeners know about a 5.25-inch floppy disk, but it's the save icon, I guess, is the way that you all know. And back then, you wrote a program that would protect the data on this disk, and then like 20 years later, you had to access it. So you had to create your own, a cracker for your own program to guess the password. And what was the password?
Ninja.
Ninja.
And I'm pretty sure it wasn't because I was into like ninja hacking at the time. I'm pretty sure it was a direct reference to the Foot Clan on Teenage Mutant Ninja Turtles there. So and the best part about Pandemic is because you can kind of just dress up like a Foot Clan member every time you go to the grocery store. So that's been fun.
That is awesome. Well, thank you again. Go ahead and take it away. I'm going to turn off my camera so we just see you.
Sure. Yeah, I've been trying to just center the presentation a little better. I think it was like better in the start. Let me just see if I
it looks
squish
perfect.
it up. It's
it looks perfect.
I'm worried that the edge is going to get cut off a little bit. If I move it up, move it over. Well, I think the edge is going to get cut off, but you know what? I think most of the content, the good content's in the middle of the screen here, so we're just gonna kind of roll with this. So, okay, it's a pleasure to be here today. I appreciate the invitation to be able to present here. Oh, I think I made it worse with that. Let me just try one more tweak. Just pull this down really quick and then see if this just makes it a little better. There's like a lag between me being able to see what's going on. Now it's all black. All right, well, this is probably going to be at about as good as we can get it. So let me just try one more tweak and then. Okay, so let's kick this thing off. Live off the land and crack the NTLMSSP protocol. So in May of this year, Bleeping Computer published an article about a new utility in Windows called PacketMon, which is a packet tracing utility that was quietly added into Windows in October of 2008. So I had a chance to play with it for a little bit, and I quickly wondered if this could be used to intercept NTLM v2 hashes off the network. And in short, it was very possible. But I had some problems using existing data or using existing tools to easily extract the hashes from the packet data. So I created a utility called NTLM Raw unhide that can retrieve NTLM v2 hashes from binary packet captures. And since this tool looks at the actual raw binary data, we don't need to worry about parsing packets at all. So it can ingest a variety of formats, including native Windows formats like .etl and .cap, as well as pcap and pcapng formats that you're probably a little more used to working with. So in this talk, I'm going to break down the NTLMSSP protocol through the lens of what are we looking for to obtain crackable password hashes. And I'm also going to be talking about live off the land binaries in Windows that can help us intercept these network hashes and show how we can extract hashes from packet dumps with NTLM Raw unhide. So just a little bit about me. I was already intro, but just things I'm interested in here. I like to make software. I like to make break software. I'm really interested in Linux and open source software, very passionate Linux user. I'm also interested in other technical, interesting hobbies, ham radio operator. I like to tinker around with hobby electronics. So, those are things I do for fun. I have been in software and cybersecurity for more than 2 decades, mostly in entrepreneurial endeavors. And because I don't like sleep, I actually currently have 3 roles and kind of fantasize that maybe one day I'll have like 1 job or 2 jobs like normal people. But right now, my roles are split into 3. So I'm the president of the software design and development firm, Eris Interactive Group, and that's a position I've held for over a decade. I'm also the co-founder and principal consultant of Savio Information Security, and we are a company that focuses on offensive assessments and security program development, mostly for small to mid-sized businesses, professional service firms. I'm also on the part-time faculty of the University of Pittsburgh School of Computing and Information. And specifically there, I'm involved with an organization called the Professional Institute, which is a new program for post-baccalaureate students who are looking to increase their skills and gain certification in cybersecurity. For that program, I've developed 2 courses, the offensive boot camps, 1 and 2. And these offensive boot camps teach students about vulnerability discovery, pen testing, adversarial tactics, and things like that. So I'm a real strong proponent of training and skill development. And really, I think I'm excited to be involved in this program because teaching's been a lot of fun. And I think ultimately the skill development, getting more people trained, will push the industry forward. So NTLM v2, sometimes referred to as net NTLM v2, is a challenge response hashing algorithm that is used on Windows networks. It's one of the authentication methods used in the NTLM Security Support Provider, or NTLMSSP protocol. So the other protocols that are used for authentication here are LM, LMv2, and NTLM v1. So NTLM v2 is different than the NTLM hash format used to store passwords in the local Windows SAM file or on a domain controller in the ntds.dit file. So NTLM v2 is part of a network authentication protocol and is not itself a hash format. There has been some debate on Twitter over do we call it NTLM v2 or net NTLM v2, because everything on Twitter has to be a debate. But for the purposes of this talk, I actually did some digging because I wanted to be accurate, and I could not find any mention of the phrase net NTLM v2 in Microsoft's documentation. I believe the term net NTLM v2 originated with the introduction of this hash type in Hashcat and John the Ripper. So The protocol itself is NTLM v2, but in my opinion, calling the resulting hash NTLM and NTLM v2 hash, or calling it a net NTLM v2 hash, are both totally okay. You just need to understand that there's a difference between the NTLM v2 protocol and the thing that's a crackable password hash. So for the remainder of this talk, I'm going to call it the NTLM v2 hash. And if you want to debate me on it, I'm happy to discuss it. I'm not passionate about one way or the other. I'll be in the virtual happy hour later, so we can chat about it then. But anyways, there are other network authentication protocols for Windows Active Directory networks, most notably Kerberos, but NTLM v2 is still widely used on today's organizational networks. I have personally never seen a network that is not using NTLM network authentication in some way, even when Kerberos is also being used. So as such, many tools in contemporary penetration testing focus on intercepting NTLM v2 hashes and authentication handshakes. So once you intercept the authentication handshake, this can be assembled into a crackable password hash. It can also be relayed to other hosts on the network without the need to crack. And the most infamous of all these tools is definitely Responder, which has been a staple in the penetration testing arsenal for many years at this point. So for those not familiar, Responder is simply a tool that responds to LLMNR, MBNS, and WPAD requests on the network. And there's a similar tool, which you might have also heard of, written in PowerShell for Windows, called Inve. There's a variety of ways Responder can intercept network hashes. Most of that's going to be totally outside the scope of this talk. It's well documented on the internet, but I will highlight one method that I personally find very enjoyable, and it was one of the first things I do on an internal penetration test, is to drop .url files on shared drives. So if you aren't aware, you can craft .url files as well as a bunch of other file types to embed UNC links to network shares on the network. When a user browses to a shared drive containing this .url file with this UNC link using Windows Explorer, it automatically creates an SMB connection to the specified link. If we can point the UNC link to our attacking machine, boom, we have an NTLM v2 network authentication hash that we can crack or relay to other hosts on the network. So if you've used Responder at all, you're very likely used to seeing this kind of blob of data that I have in this screenshot. And so this is a NTLM v2 SSP hash. The thing is that you might not be aware of what happens behind the scenes, how this data is assembled, and you may not actually be aware of the actual fields here. I certainly wasn't until I pulled back the the envelope and looked inside to see what's happening. So let's discuss. NTLM SSP is an authentication protocol. It's a three-way handshake client server. It starts out, the client sends a negotiation packet to the server. The server responds with a challenge response, and then the client sends an authentication response to that challenge. Now, Santa's, oh, I hear something in the headphone, or not?
I heard it too, but I'm not sure who it was because everyone else is muted. So continue on. Though.
Phantom guitar playing or something. Okay. I should also note that my neighbors are having their sewer line dug up today, but I think all the jackhammering's done at this point. So so I think we're good for that. So anyways, clicking forward, the Santa drop kicking. Maybe it was the Santa drop kicking. By far the best link on the internet, if you're interested in this, in how this protocol works, is right here, NTLM Authentication Protocol and Security Support Provider. This link is a gem. It has all the methods about how the authentication works, the packet offsets, and basically without this link, I wouldn't have been able to easily develop this tool. So I probably have been able to do it. Maybe I wouldn't have actually went through the hassle, but it's an excellent link. I highly recommend it if you're interested in understanding more about how this works after the presentation. So let's talk about the 3 message types. Message type 1 is negotiation, and this is sent from the client to the server. And this message initiates the NTLM authentication process. It also provides the server with a list of features requested by the client. And we can identify this by the message header NTLMSSP followed by a null and then a 0-1 padded out to 4 bytes. From a cracking standpoint, there isn't any information that we need to extract from this negotiation method. So we'll just note it and that a new request has been made, and then just move on to the next type 2 message. So type 2 message is sent server to client, and it's in response to the client negotiation. This list includes a list of features that the server will actually support for the client, and it's again identified by the NTLMSSP null and the 0-2 padded out. The type 2 message contains a field that we'll refer to as the server challenge, and this is the first piece of data required to build our crackable password hash. The server challenge is an 8-byte block of random data, and it's located between bytes 24 and 32 in the type 2 message. The server challenge is used in the type 3 message next to prove to the server that the client actually has knowledge of the user's password. And the third message type here is the authentication method. And again, it's really easy to find in the binary data. It's NTLMSSP, a null, and 0-3 padded out to 4 bytes. And this is probably where most of the action happens, most of the interesting things from our perspective for assembling crackable hashes. So the server challenge is used to formulate the challenge response that proves to the client that proves to the server that the client has knowledge of the specified user's password without the need to actually send the server the clear text password or the user's NTLM password hash. It also includes the username, the domain, and originating workstation name, which are all useful fields when you want to construct crackable password hashes. So I've indicated on this slide how to find these pieces of data. It's really easy visually locating it, but essentially the way it works is after the header, there's a variety of fields, and these fields indicate the length of the type of data you're looking for and the offset within the packet of where this data is located. Obviously, byte 0 is at the start of the NTLM SSP message header, and then you just work off that offset. So it's actually pretty easy to parse this data when you're looking through it. Now, a client can respond to the server challenge in one of several ways, and that is the LMv2, NTLMv1. It can also be an anonymous or null session, and of course, NTLMv2. Now, for the purposes of this talk, we're going to focus on NTLMv2 because this is the most widely used version on today's organizational networks. Now, there's also the blob. All right, so the blob, basically the NTLM authentication response message. So this message response is the blob of data that includes the timestamp, an 8-bit client nonce, and a handful of other fields that aren't really important for us to discuss right now. This is concatenated with the type 2 challenge. So once all that data is blobbed together, an HMAC MD5 of this blob is generated, which results in a 16-byte value, which we'll refer to as the NT proof string. The reason I'm referring to it as the NT proof string is because this is what Wireshark calls it, and I couldn't find any other actual phrase that described it. So the so the data blob is then concatenated to this HBAC MD5 NT proof string. The details itself are a little more complicated, and I'll point you back to that Davenport URL that I referenced earlier. But essentially, the NT proof string and the blob are sent by the client to the server to prove to the server that the client has knowledge of the requested user's password. So all the magic happens here. Now, once we've been able to obtain all this data from the 3 messages, we can extract that and assemble the crackable hash. So crackable hashes for Hashcat and John the Ripper go in this format. So it's domain/username, 2 colons, and the reason there's 2 colons, people are always really curious, it's because this is where the password goes after you crack the hash. So after the 2 colons goes workstation, server challenge, NT proof string, that's that 16 bytes, and the rest of the NTLM v2 response minus that NT proof string. And of course, you end up with a blob of data that looks like so underneath. Now, getting into some more interesting things. Living off the land and intercepting these hashes. So there's 2 live off the land or LLL bins in Windows that can help us intercept network hashes, and that's NetSH and PacketMon or PKTMon. So NetSH has been around since Windows 2000. It's an ancient utility. According to Microsoft, it's a command line scripting utility that allows you to display or modify the network configuration of a computer. This utility also provides a packet trace feature that allows for capturing network data. The output format of NetSH is .etl. Another utility, which is newer, which I mentioned in the start of the presentation, is pktmon.exe or packet monitor. And this provides a much more robust packet capturing feature over NetSH. It's more akin to TCP dump on Linux. It was first introduced in Windows 10 and Server 2019 in version 1809. And it's continuing to receive improvements to this day, just notably in the recent release of Windows version 2004. It adds support to convert the output log in PCAP-NG format, which is certainly useful. And if you're using a previous version before Windows 2004, it's going to output to a .etl format, and ETL still remains the default here. Now, even better in Windows 2004 is this new real-time listening option, which is awesome for our purposes here. Without the real-time functionality, the way Packet Monitor works is actually really similar to NetSH. It collects a bunch of data. When you eventually Control-C it, it compiles the data and spits it out to disk. At that point, you can analyze it using my tool or doing whatever else you're going to do with a packet dump. Real time lets you see the data and interact with it in real time. Now, as I mentioned in the beginning of the talk, I found it difficult to work with the .etl format output by these tools. And that's why I ended up developing this tool, NTLM Raw Unhide, to retrieve NTLM v2 hashes from the packet dumps. I fully intended to read the Bleeping Computer article, figure out how to extract figure out how to capture NTLM v2 hashes, load it into Wireshark, and write a blog post. And I figured it would take a couple hours to do that. What ended up happening was I couldn't get the ETL format to really work too well. There are some utilities. You can turn an ETL to a .cap file in Windows using this utility called Microsoft Network Monitor, different than the Packet Monitor tool. It works, .caps can be loaded into Wireshark, but the nice parsing features that you're used to in Wireshark when analyzing data aren't present if you load a .cap file in there. Wireshark does have another utility called edit cap that you're supposed to be able to convert this dot cap to a P cap, but it just didn't work for me. I'm not sure if there's a problem with the tool, if it's still supported, or maybe there's something different about how the packet capture data is, being collated by Packet Monitor. I'm not really sure. It just didn't work. There's also this ETL to PCAP-NG utility that Microsoft provides, but again, I couldn't really easily get the data I wanted. And even if I could, going through Wireshark and manually assembling the hashes by hand is not really all that fun. It's error prone. So I set out, I tore open the covers of NTLMSSP protocol and figured out how it actually worked, and then developed this tool. So NTLM Raw Unhide works with NetSH and Packet Monitor, as well as TCP dump and Wireshark, and probably any other utility that spits out binary packet capture data. It's pretty easy to use. It's a pretty basic tool, actually. It just does something useful that I couldn't do before. The tool provides options to ingest an input file for analysis. -O, we can output the found hashes to a file. We can also -F, and this is my favorite feature, is kind of like tail -F. So -F follow file for real-time analysis. And clearly, this pairs really well with Packet Monitor's real-time option. It also works really well if you're just pulling packet data with TCP dump in real time and dumping it out to a file. So this next screen here, we can see the tool in action. I did a screenshot here because the next one has a video, and if the video doesn't turn out well on the screencast, we can at least see how it looks here. But here's the tool in action. And on the project's GitHub page, there's a /examples directory, and I have a variety of packet captures in different formats that you can use to test the tool and obtain a crackable password hash. And spoiler alert, the super secure password I was using for my workstation for these tests is MikeG123. So if you can crack it and get MikeG123, you're in business there. But here we just see how the tool works. So you fire it up, and it found one hash in this dump. The type 1 message, negotiation, type 2 challenge, it notes the server challenge, authentication data, and then it outputs the network hash. Now, let's see. Pretty sure this will work. It worked in my tests. We're going to try to load up a video here of it in action, and I will narrate kind of what's going on, but I can tell you that I'm going to have to pause it really quick because the quality, for some reason, defaults to a very poor quality. All right, that should at least make it a little visible. This same video is on my website, so if you can't see it here, you can at least see it later. But what's going on here is we have two terminals open, and in the terminal on the right, I'm setting up a network share on a Windows machine that we have administrative access to. I'm also setting up Packet Monitor to listen on port 445. This is going to look for the SMB connections. Then on the other screen, I'm going to fire up NTLM Raw Unhide. I'm going to be following that file. And then I'm sending over network authentication requests to the workstation here. And you can see them come through here. Steve Brule from Channel 5, Uncle Muscles, Casey Tatum. If anybody knows like what these are references to, you're cool. But and as the packets are captured by Packet Monitor, they're output to this tool. And then I've also used the output feature of the tool to just kind of assemble all the data to file here. So you can throw that file into John the Ripper or Hashcat and get cracking. And again, well, actually, no, that wasn't MikeG123. I can't remember what the password I used for those was. But a couple things I want to note here. Like I mentioned, this does require local administrative access to use. So this is something that you'd use as part of post-exploitation. And setting up a network share, you need to set up a share. If the machine doesn't already include a network share, you need to do that so the host has something to authenticate against. But again, you already have local administrative access on the machine, so it's easy to set up a share with a command. I should also mention here, although the video had both tools running inside Win 10, I had actually, that was the other terminal is Kali Linux running in Windows Subsystem for Linux. I want to note that there is absolutely no requirement to run NTLM Raw unhide on the same machine as the packet monitor. I just did that for video recording purposes because it was clean, getting in one shot. But essentially, as long as you can get that packet dump off the machine to another machine, you can run NTLM Raw and hide on it. If you can do it in real time, that's even better because then you can actually analyze the data. Obviously, there might be some delay there in transmission, but near real time observation of that. I also want to mention that there is absolutely nothing special about SMB. We're just choosing port 445 and SMB because it uses NTLM v2 authentication. It could easily be WMI, WinRM, any protocol inside Windows that has a network authentication that's handled by NTLMSSP will work with this tool. So let's see, there we go. So, you know, we're at our conclusion here. I just want to say a couple extra words in terms of defense. I think the biggest red flag in the video example is that there was communication happening workstation to workstation, or server to the workstation versus the workstation initiating the connection. This should really never happen in an organizational network. Communication should always be workstation to server, and you never need other workstations on the network communicating with each other. So that would be a red flag, I think, that in terms of detection of a technique like this. But what if we pop a server, like a file server? That would be really great because everybody's always authenticating to it on the network. In terms of pen testing, that would be really great. But in terms of detection, you need to monitor these utilities. There is nobody on your network that's ever going to have to run NetSH or PacketMon outside of maybe IT occasionally. So if these utilities are being run on a machine, then certainly it's a red flag. And also just restricting administrative access. If you're a local admin on a machine, then you can easily just fire this up and start collecting packets without detecting antivirus or anything, because these tools are used inside Windows itself. So, that's probably my 2 cents on defense. I'm more of an offensive guy, so a lot of you might have better ideas, and I hope you do. It's just what I want to present on a new technique here. Now, in terms of future work, NTLM v1 is something I'm thinking about including because just recently, as of this week, last week, I actually was doing an assessment and I obtained an NTLM v1 hash. This has actually happened a couple times this year through old scripts or devices on the network that are still spitting out the old format. So it's still out there. So it would be useful to add into the tool. So also want to look at SMB relaying. I don't think it's possible to do SMB relaying with this tool and this technique. The reason being is SMB relaying is more of a man-in-the-middle technique, and it really requires you to stay in between the authentication, and you need to be able to take that authentication request, pass it somewhere else, and then send back a deny request to the originating client. Because of how this works, I don't think those cards can really line up in such a tool. Something I'm playing around with, and I certainly will learn something out of it about how relaying works by trying to implement it. But I wouldn't hold your breath that I'm going to be able to get SMB relaying to work in this tool, but we'll try. Anyways, that kind of brings us to questions. The project GitHub page is there. If you're interested, it's just Python 3 script. My personal website has a blog post about this, basically this talk in text format, and Twitter. I'm not ashamed to say that I like to get Twitter followers, so if you feel so inclined to follow me, I try to talk pretty strictly only about technical topics and cybersecurity things. So I'll turn it over to questions.
Hey, all right, thanks for that. I was actually looking up on Twitter right now, but we have a question here. I think you covered it, but maybe just reiterate. The question is NTLM version 2 not encrypted during transit?
So it's not encrypted, it's hashed. So NTLM v2 is the protocol used to protect the actual password hash and the actual so what NTLM v2 authentication does, it prevents the NTLM hash from flying around the network like you might see with pass the hash attacks, and also prevents the clear text password from flying around the network. So this process is the authentication process used to conceal that data. But like any password hash, it has to, if you can obtain the portions of it, you can crack it. So it's not encrypted in any way, but if we can, it's a slow password to crack. Like, it's not fun cracking NTLM v2 passwords at all. It's much better to relay them. But if you can get it, and I mean, I've cracked these on many assessments, and I think, oh man, I can only, for some reason, I wasn't able to relay a hash. Maybe the user didn't have admin access or something. You're only stuck with cracking, and they do crack. I mean, most people are still using something based on the dictionary words. So I hope that answers the question. If not, I'll be in Discord there.
Excellent. Yep. And just as a reminder, we're on the expert-track channel on the GRIM Discord. I want to take this time to thank you. Awesome talk. Definitely going to check out these tools and see what we can get out of them. So really appreciate that. Appreciate you giving back to the community, and of course for your time giving a cool presentation. We had a lot of folks saying that they loved your Who Am I page, your man page of yourself.
Yeah.
So
I tried to do something different than the standard Who Am I, so I came up with that. And carbon.now.sh creates all those really cool terminal screenshots. So if you want to check that out.
Yeah, no, it was super cool. Awesome. Well, thank you again for your time, and we'll chat with you on Discord.
I appreciate it. Thanks, guys.